when a charged particle moving in a uniform magnetic field. See, Q is the charge. Let us say positive charge, and m is equal to its mass. V is equal to its velocity, and this charged particle, positive charged particle, is entering in a magnetic force. It will, when it is entering in a magnetic force, it will experience a magnetic force due to the magnetic field, which is given by Q is equal to V cross B, where B is the magnetic field, and its magnitude is given Fm is equal to QVB sine of angle between them. See, if it is like this, see, this is the plane, this plane, this is velocity vector, this is magnetic field vector, and this is angle between them. By right hand thumb rule, we have to move from V to B with the right hand palm rule. V to me, it will be in the upward direction. The magnetic force will be in the upward direction. This we have repeated. And also the magnetic force is perpendicular to magnetic field, and magnetic force is perpendicular to the velocity of the particle. This is, it means this and this are perpendicular, this and this are perpendicular. Therefore, it will experience a force, and the direction of force is always perpendicular to the velocity of the velocity vector and magnetic field vector. Velocity means the charge moving with a velocity. If the particle is moving at right angles, to the magnetic field, see here, F is perpendicular to V. If the particle is moving at a right angle, that is at 90 degree with magnetic field. It means what? The angle between V and B. Theta is equal to 90 degree, and magnetic force on the charged particle is equal to QVB sin 90. QVB into sin 90. Sin 90 is equal to 1. Therefore, Fm is equal to maximum force, which is equal to Q into V into B. So, if the particle move at right angles, that is, particle is at right, this is the velocity vector, this is the magnetic field at 90 degree. If the particle moves at right angle, that theta, with the magnetic field, it means F is perpendicular, a force, as it is seen, force is perpendicular to B by using the right hand thumb rule or Fleming's left hand rule. It means this is perpendicular to V, this implies, because F also perpendicular to displacement. Why? Because whatever direction is the velocity, same direction the displacement will be there. It means we have already seen F dot, it means work done is equal to F vector dot displacement vector. Therefore, work done is equal to F into S into cos theta, or work done is equal to F into S into cos 90 degree, because this and this are perpendicular. It means the angle between F and S is 90 degree, cos 90 is equal to 0. Therefore, work done is equal to 0. By work energy theorem, what it says, work done is equal to 0, which is also equal to change in kinetic energy. Change in kinetic energy. Change in kinetic energy. So it means we can say change in kinetic energy is equal to 0, that is delta kinetic energy is equal to 0, that is kinetic energy final minus kinetic energy initial is equal to 0, that is half into m v square, that is final velocity is v, and half into m into u square is equal to 0, or half m v square is equal to half m u square, where u is initial velocity, v is final velocity, or v square is equal to u square, or v is equal to u. This one fact. Another fact, kinetic energy final is equal to, or we can write kinetic energy final is equal to kinetic energy initial. Therefore, if a particle moves at right angles, what are the things? By work energy theorem, speed and kinetic energy do not change in moving. When the speed and kinetic energy of the particle do not change when the particle is moving in the magnetic field at right angles, but the direction of the particle will change. The direction of the particle will change. Therefore, for a positive charge, the force continuously deflects the particle. See, this is the magnetic field, and the particle is moving like this. With velocity. What will be the direction of force? See, now we will see Fleming's left hand rule. This is the direction of magnetic field, and this gives the velocity and the force by the thumb. The force will be this direction. This is a magnetic field. Force due to magnetic field is in this direction. Because of this force, inward force, it will get deflected like this. Again, there is a magnetic field, and the particle, due to inertia of direction, particle will move like this. Again, it will get a force Fm like this. Like this. It will get a force like this. This is the magnetic field and this is the velocity. It means what? The particle will tend to move in a circular path. That is, if the particle is moving in this direction, and this is the direction of magnetic field, and the particle is moving like this. It means this is the magnetic field direction, particle is moving, the particle is entering at 90 degree with the magnetic field. Therefore, for a positive charge, the force F continuously deflects the particle and move along a circular path without changing its speed, because the speed is always same. The speed always remains same. It means here at this point, we see you use Fleming's left hand rule, magnetic field inside, the particle, see if it is moving, here it will move like this, velocity, this is the direction of force. And like this it get deflected. Let us check up at this point. The velocity will be tangent at this point, because velocity, and this is the magnetic field, velocity like this, and the force will be this way, force. Same way here also, this is the velocity direction and Fm in this direction. Same way here, Fm. You can check up using Fleming's left hand rule. Here let us check up. This is the direction of magnetic field, and this finger gives the velocity and this one gives the magnetic field. Therefore, the path of the charged particle is circular when it enters the magnetic field at right angle, because the magnetic field is, when this particle is at right angle with the magnetic field, here this is at right angle, theta is equal to 90 degree, because magnetic field this side, magnetic field is into the board, and this is the velocity vector. So we can say, we have to note this point, this is used in cyclotron. The path of charged particle is circular when it enters the magnetic field at right angle. So it means we have already seen for a circular motion, there has to be, for a body to move in a circular fashion. See, this is the body is moving in a circular fashion. What are the things happen? See, at this point it moves, the velocity will be like this. The particle will tend to move this way due to inertia of direction, because it cannot change its direction by its own. So there has to be some force, that is some force, which we call it as a centripetal force. Petal force acting so that you don't move this way, move this way. Again at this point. So this centripetal force keeps this body moving in this direction along the path of the circle. Here, if it is moving like this due to inertia, there will be a force centripetal towards the center. Here also, if the particle is moving like this, there will be a force, so that every time when the particle is tending to move in a straight away, there is a centripetal force acting on the body, so that to keep the particle in the circular path. It means to keep a particle moving in circular path, a centripetal force is required. Now here, which is doing the centripetal force? The centripetal force is provided by here, what is this? Particle is moving this way, and this is magnetic force acting here. It is trying to move like this, magnetic field. So it means the magnetic force, Fm, is responsible for keeping the particle to move in a circular path. So this centripetal force for the particle moving in magnetic field at right angle is given by the magnetic force. So it means we need a centripetal force for the body to move. If it is moving like this, there has to be some force that is given by the magnetic force. Here also, body will tend to move like this. There has to be force towards the center. The centripetal force always acts towards the center. The centripetal force, you must have seen you must have read in the +1 physics, in a circular fashion with a particle moving with constant speed. To keep it in the circular path, a centripetal force is required, and the direction of centripetal force is along toward the center of the circle with the radius, orbit the circle with the radius r. So the centripetal force, that is mass m, mass into velocity square by r, is the centripetal force, which is provided by the magnetic force. It is provided by the magnetic force. In this case, we can write. Now magnetic force, what is magnetic force? See, it is moving at QVB, it is moving at 9, the angle between V and B is 90 degree. If it is 90 degree, it is 90 degree, Fm is equal to QVB, because we put here 90 degree, sin 90 is equal to 1, so maximum force is equal to QVB. So or we can write M V square by R is equal to Q into V into B. With this we can find out R. R is equal to M V square by Q into V into B, or R is equal to MV by QB, where B is the magnetic field, Q is the charge. So the radius of the circular path, where R is equal to a radius of circular path. The circular path, the particle, when it is the charge particle, when entering inside a magnetic field at right angles, it will traverse a circular path, and the radius of the circular path is given by R, which is equal to mv by qb. R is equal to R. R can be written as V divided by Q by B, Q by M into B. It can be written as where Q by M, what we call the Q by M, is a charge to the mass ratio. Q by M is charge to mass ratio, or we can call it as specific charge. So now we have find out the radius of this one. Now we will find out the time period. When a body is moving in a circular fashion, it will have a time period, and it will have frequency, and it will have angular frequency also. So far we have seen all this one. Now the radius of the circular orbit is given by m, mass into velocity divided by charge into magnetic field, or r is equal to velocity divided by q by m into b. Now since it is moving in the circular path, it will have time period also. What is time period? If it is starting from here and makes one complete circle, what is the time to complete one cycle? That is called time period. So time period of rotation, that is one cycle, one rotation, one cycle. Time period, we can call it as a time period. See, velocity is equal to displacement by time, or time is equal to displacement by velocity. So time period is equal to displacement by velocity. What is here the displacement? Suppose we start from here, it makes one complete revolution. The displacement is nothing but the circumference of the circular path is equal to, so time period is equal to circumference of circular path, divided by the velocity of the particle. Therefore, time period is equal to circumference 2 pi into radius, circumference of the orbit, divided by its velocity. So velocity, now we can go for the velocity. 2 pi, what is t? 2 pi r, what is the value of r? T is equal to 2 pi divided by v into 2 pi divided by r is equal to m v by q into b. So time period is equal to this v we can get cancelled, 2 pi m divided by q into b. This is the expression for the time period. This is the expression for the time period, q by time period. And frequency is given by is equal to frequency means how much circular motion it makes in 1 second. That we call it as a frequency. So frequency means frequency is given by 1 by time period. So 1 by time period, so frequency is equal to qb divided by 2 pi into m. This is the expression for frequency. This is also known as cyclotron frequency, because this funda we are going to use in the cyclotron. qb by 2 pi m is this frequency is known as cyclotron frequency. Okay, when a charged particle moves perpendicular to a magnetic field, it moves in the circular path in the magnetic field. Now we have to find out the angular frequency. Angular frequency is equal to 2 pi into linear frequency. This is linear frequency. So angular frequency is equal to 2 pi into linear frequency is equal to qb by 2 pi m. This cancels. So angular frequency is equal to angular frequency, which is equal to QB by M, and the linear frequency is equal to QB by 2 pi M, and the time period is equal to 1 by frequency. So we will use this symbol because most of the books use this symbol. Frequency is equal to, reverse it, that is 2 pi M by Q into B. This is the time period of this one. So this angular frequency is also known as gyro frequency. This angular frequency also known as gyro frequency, and this is linear frequency. It's called cyclotron frequency. See, this funda we are going to use in cyclotron. That is, whenever a charged particle enters in a magnetic field at right angles to it, then it will undergo a circular path motion. This is the funda we are going to use in cyclotron.